Hi everyone. In this video we're going to talk about the idea of mutually exclusive events. And two events are said to be mutually exclusive if they cannot occur together. So I would encourage you to pause the video for a minute and see if you can think of any examples of events that would be mutually exclusive, things that can't happen together. The first example that comes to my mind is a deck of cards. They're very common to use in probability as examples. And I know that in a deck of cards, drawing a red card and a black card are mutually exclusive. I cannot do both at the same time. In a standard deck of cards, the cards are either red or they're black. They are not both. So I cannot do them together. An example of two events that are not mutually exclusive, things that can happen at the same time, I could draw a red card and a queen. I happen to know in a standard deck of cards that there are two red queens, the Queen of Hearts and the Queen of Diamonds. So mutually exclusive means they cannot happen together. They exclude each other. Not mutually exclusive means they can happen together. There is some overlap. From another example, we looked at rolling dice in our last video. For mutually exclusive, rolling an odd number and an even number would be mutually exclusive because my die face can either be odd or even, 1, 3, 5 or 2, 4, 6. Those two lists of numbers don't have any overlap, so they can't happen at the same time. For an example of not mutually exclusive, I could do rolling a number less than 3 and an even number, because the numbers less than 3 would be 1 and 2. Even numbers are 2, 4, 6. 2 lives in both of those events. 2 is an even number, 2 is less than 3. There's overlap, so they're not mutually exclusive. So we're going to go ahead and consider some situations and determine whether they're mutually exclusive. So the first one is drawing a card, getting a spade and a 6. And these are not mutually exclusive because the 6 of spades exists in the deck. Anytime I have something that's both at the same time, they're not mutually exclusive. And next, I roll 2 dice. We're going to assume that they're 6-sided. And I get a sum of 7, or I get doubles. In this case, these guys are mutually exclusive. And the reason they're mutually exclusive is that doubles are always going to be a sum that is even. Because I'm taking a number and multiplying it by 2, right? 1 plus 1 is the same as 1 times 2, which is 2. 3 plus 3 is 6. 5 plus 5 is 10. Anytime I double a number, I get an even result. Whereas 7 is odd. So I cannot be in both at the same time. No overlap. For the next one, it says select a student at random in your class, get a male or get a sophomore. And this is another not mutually exclusive because I can be both male and a sophomore. That is possible. Matter of fact, I'm sure there's at least one person in our section specifically that meets that requirement. So if they can exist in both places at the same time, not mutually exclusive. The last is select any college course. It is a calculus course or it is an English course. And those are ME because they are taught by different instructors in different departments. I do not know any English professors that would want to teach a calculus class, and I don't know any calculus professors that would want to teach an English course. Different subjects, different teachers. I shouldn't be sitting in both classes at the same time. The reason we're going over mutually exclusive is because where events fall, either not or mutually exclusive, depends on how we treat them when we start calculating probability. So in our fourth video for this week, we'll start seeing how this determination affects the math that we do. If you have any questions, feel free to send me an email or drop by our Thursday office hours. Otherwise, I'll see you in our next video.